Hello everyone, good morning. Welcome to Technical Route. Today, let us learn about the JDK, JRE, JVM, and JIT compiler. Let us learn what is JDK, what does it contain, JRE, what does it contain, JVM, and JIT compiler. First, see what is an JDK. Now, when you go for an interview, if there are questions based on the Java, they can ask and questions based on these topics JDK, JRE, JVM, and JIT compiler. When you ask a question for you, what is an JDK? You should not go first into definition. First, you have to say what does it stands for? What does the JDK stands for? The JDK stands for an Java Development Kit. Java Development Kit. JRE is in Java Runtime Environment and JVM. JVM stands for a Java Virtual Machine. JIT. JIT stand for a Just in Time. See, these are the abbreviations of the JDK, JRE, JVM, and JIT. First, you have to say the what does the JDK stands for, and then later you have to go for the definition part. The JDK stands for an Java Development Kit, and JRE stands for an Java Runtime Environment, and JVM stands for an Java Virtual Machine, and JIT it is a just in time. These are the abbreviations for an JDK, JRE, JVM, and a JIT compiler. Now, see what is JDK. What is a JDK? This JDK is a Java Development Kit. In this JDK, the developer is going to write the code. It provides an environment to develop and run the Java program. It provides an environment to develop and run the Java program. It is an environment to develop. Here the developer is going to write the code, and it going to compile the code and execute the code. It is an compiler and the software development environment. And these JDK contain and JRE and development tools. JDK contain and JRE plus development tools. The JDK contain JRE plus development tools. Now next is JRE. JRE, it isn't just an environment. Whatever the development code is done in the JDK, that code has been going to run the program and executing in the JRE, that is a runtime environment. It is just an environment to run the program which or whatever the developed program are there, that program has to be going to run in the JRE. And this JRE will be having a JVM. It already contain a JVM also. It is an implementation of the JVM. It is an implementation of JVM and it is a physically exist also. It physically exist. Now next is a JVM. And this JVM is an abstract machine, and it is a specification. It is used for an convert the bytecode. It is an execute the bytecode into a bytecode is executed in this JVM also. It is an abstract machine, and also it is a specification that provides runtime environment in which a Java bytecode can be executed. The bytecode which is sent it to an JVM that is executed in the, and here there will be a machine code will be there. The bytecode has been converted into a machine code in the JVM. This bytecode has been executed in this JVM. Now let us see how it is going to be there. This is an JVM. Sorry, this is an JDK. This is an JDK. Then inside the JDK, the JRE will be there. Inside JDK, JR will be there. And inside this JRE, JVM will be there. The outer layer is an JDK, which is an biggest one. Inside this JDK, the JR will be there, and inside this JRE and the JVM will be present. If we need an JVM, then we should install the JRE. If we need this JVM, we need to install this JRE. If we need this JRE, we don't need to install this JDK also, because it will be installed. It can be installed JRE and JDK separately can be installed until 1.8. We can install this separately. Now in this JDK, we know that there will be a JRE plus development tools will be present. They contain a JRE plus inside this JRE, inside this JDK, JRE plus development tools will be present in the JDK. In this JRE, there will be an runtime tools There will be a runtime tools plus and library. There will be a runtime tools plus library. In this library, there will be a Java internal classes. This library contains Java internal classes. In these JRE contain and runtime tools and libraries, and also contain a JVM inside this. And these tools has been sent it to a JVM. This JVM contains an class loader subsystem, class loader subsystem plus and runtime data areas plus execution machine, execution engine plus and native libraries. These JVM contain and class loader subsystem, runtime data areas, execution engine, and a native libraries are there in the this JVM present here. These all are helps for the execution. These are helps for an execution process. In this JDK, I already told you that the developer is going to write the code and compile the code and execution purpose. Inside this JDK, when we are working with the JDK, it has a .java file. And the developer is going to write the code in that, and that file has been saved as a .java file has been saved as a .java file, and this .java file has been sent it to the JRE. This .java file has been sent it to the JRE, and it is converted into a .class file. This .java file has been converted into a .class file. Here the compilation has been happening. In this JRE, the compilation has been happening, and it has been compiled into a bytecode. And what are the .java file, what are the code is present, that code has been converted in, that source code has been compiled into a bytecode. Here in this JRE, it's going to compile into a bytecode. This bytecode is an it is a platform independent. The bytecode is a platform independent. It is a platform. The bytecode is a platform independent. It is an intermediate code. This bytecode is a platform independent. It is an intermediate code. It does not contain any high level or low level code. It just contains intermediate code, and this bytecode will help for the Java to achieve a security. It helps in the security purpose also. And you're going to convert it in a .class file, and these has been sent it to the JVM. This then send it to the JVM, and this bytecode has been converted into a machine understanding code. And that is going to convert it to a machine understanding code. There will be an interpreter in this JVM. This JVM interpreter will convert an bytecode, that is .class file is converted into an bytecode, that is an machine understanding code will be converted. How it is working in the how it is internally working in the Java means execution. First, whatever the development code has been there, that code has been saved as a .java file. This Java file has been sent it to the JRE. It will convert into a class, that is there compilation has been happening in the JRE, and this .class file has been sent it to the JVM, that will convert into a machine understanding code. So here in this in this process, there will be an happening of an compilation is also happening and an interpretation also happening. In the interpretation type, it will a line by line execution will be happening in the JVM. So for these reasons, the Java is called as a compiler and interpreter language. Both will happening in the process. When you execute the code, both of them will be happening. First, we will going to compile and then it is going to interpreted. It will check and both line by line execution will be checking. These are about the JDK, JRE and JVM. And then the last one is a JIT compiler. The last one is a JIT compiler. This JIT stand for a just-in-time compiler. Just-in-time compiler is a component of a JVM. It is a component of a Java virtual machine. And one more point, this Java virtual machine, this JVM isn't platform dependent. This JVM isn't platform dependent. And this JVM, it dynamically compiles the Java code and it is executed as a machine code. It dynamically compiles Java bytecode. It compiles a bytecode into a machine code. That machine code can be understood by the computer. At runtime, it is going to convert and bytecode into a machine code. And this JIT is a part of the JVM. This is also a part of the JVM. It does not convert complete Java program into executable code. It does not convert and complete Java code into executable code. It just executed whenever it is needed. Whenever it is needed, on that time only it just execute the code. It does not convert completely a Java code. And these are used for improving the performance of a runtime. It is used for an improve the performance using the runtime. It is used to improve the improving the performance using. It is used for an improving of the performance using a runtime, and it does the task of an compiling parts of a bytecode. It do the task of an compiling part. What are the compiling parts? Whether it will do the compiling parts of an bytecode that should have a similar functionality. It should have a similar functionality at the same time. At the same time, it will reduce the amount of a compilation process. This JIT compiler, this is a just-in-time compiler. It will reduce the amount of a compilation time of the run code. That is, code has been done. It will reduce the compilation time. These are about the JDK, JRE, and a JVM and a JIT compiler. These can be whenever you go for interview, if it is a question based on this Java, then the interviewer will definitely ask a question based on this. First, you have to say what does it stands for and what does the definition, what does it contain, and how it is working. This how it is going to working. First, there will be a JDK will be there, and these JDK and these JRE are the tools. These both are the tools, and this it can't be installed explicitly. This JVM that can't be installed explicitly. And what does it contain? This JDK, JRE, JVM. What does it contain? How it is going to execution process? How it is going on? All you need to be explain. If you ask in brief it, explain it briefly, or execution process, you can explain like this only. Thank you guys. I'm going to end here.